Assalamu alaikum. Numerical methods in engineering with MATLAB. This is lecture number 6. We are still explaining the basics of MATLAB. Okay, now we will explain in this lecture a very important subject, which is flow control in MATLAB. In fact, to enable the implementation of computer algorithms, a computer language needs control structures for repetition, for conditional execution, and for comparison. In fact, we will consider these in reverse order. We'll start from comparison. Comparison is achieved with relational operators such as less than operator, less than or equal operator, greater than operator, greater than or equal operator, and not equal operator. All of these operators are very important in comparison. The result of applying a relational operator is a logical value. The result is either true or false. So let's take an example. For example, assume that a equal 1, so equal 1, b equal 2. Okay, now assume that z equal a greater than b. Now if the answer is true, so z is equal 1. If the answer is false, z equals 0. Now in this case, z is false, so it is 0. If we change, for example, instead of using greater, we use less than operator, so the statement is false. Now z equal, the statement is true, and the statement is true, so z is equal 1. We can also use a combination. We can use a combination to combine logical expressions with and or to, for example, to change a logical value with not operator. So let's take an example for this. I think if we use a is greater than b, we combine them with, for example, with or. Okay, so a is less than b. Now we have two logical operators combined with or operator. Now a is greater than b, it is false, it is 0. A is less than b, it is 1. So the answer, I think, 0 or 1, so the answer is 1. If we, for example, change the or operator with and operator, so the answer in this case 0 and 1, so the answer is 0. So this is very important in our study. Now let's okay, now we'll go to conditional execution. The conditional execution is very important. We use, for example, plain if, which is very simple. We also use if else. In this type of conditional execution, multiple choices are allowed with if else and if else if constructs. Also, if else if constructs, it is good idea to include a default else to catch cases that don't match a preceding if and else if block. So I think those statements are very easy. So let's take an example. For example, with the plain if. Now, okay, let's go Now assume that a equal to 1, for example. A equal 1. Now, okay, a equal 1. If a is greater than 0, if this expression is true, so we execute this statement. So a is positive. Now assume that a equal minus 1. A equal minus 1. So this statement is false. This expression is false. So we don't execute the statement. So nothing is written here. Nothing is written here. Because a is equal minus 1. Assume that a equals 0. Okay, a equals 0. So if a is greater than 1, display a is positive, for example. This is just to show up. Now end. Now a is 0, so this statement is false. So nothing is written here. Nothing is written here. Sorry. Nothing is written here. Now if a equal minus 1, if a is equal minus 1, so nothing is written as well. Clean screen. Now let's start use if else. So assume a equal 1. Now if a is greater than 0, okay, display a is positive. Okay, else display a is either 0 or negative, for example. Okay, and end. Okay, now this expression, now we defined a to be equal 1. Now let's use this. If a is greater than 0, so a is positive. This is, if this expression is true, we will execute this statement. Otherwise, execute this statement. In our case, a is greater than 0, so we will execute this. We'll execute this statement. So a is positive. It is good to practice here to explain the meaning of this display. Display, it is one of the output functions. We have, I think, we will use in general 2 different output functions. We use fprintf, which is, I think all of you is familiar with fprintf, and we use also display. Display is easier than, or simpler than fprintf, because fprintf, it is sometimes we use too many formats in fprintf. I think I don't want to spend too much time explaining those functions. During our study in MatLab or in numerical methods with MatLab, we will talk about this function. But in general, display means print out what's inside the brackets. I think there are too many exceptional cases that need more explanation. I will leave it later on. Now, if we want to use now else if. For example, let's complicate this function. For example, assume that a equal, so for example, a equal 1, a equal 1. So okay, a equal 1, if copy, if a is greater than 0, display a is positive. Now else if a is less than 0, let's say display okay a is negative. Okay, now else display a is 0. Okay, this is end. Now because a is greater than 1, so a is greater than 0, so we will execute this statement. Let's take another example. Okay, assume that a, so okay, assume that a equal -1. Okay, now in this case if a is greater than 0, okay, display a is positive, else if greater than 0, less than 0 is negative, else if is 0. So now a is negative, so this statement will be executed. So once we just enter, so a is negative, a is negative. Assume that a equals 0, a equals 0. Now in this case this statement will be executed, so a is 0. I think it is very easy. This is very, very easy. All of you are, I think, are aware of such a flow control, but I think I am explaining this as a matter of memorizing your ideas. Now I think let's go to see if there is something important need to be explained. Now okay, the switch control. The switch control is one of the important flow control used in MATLAB. A switch control is useful when a test value can take on discrete values that are either integers or strings. The syntax of flow control is shown here. So this switch expression. Here the switch, which is the name of the flow control. This is the expression. If we have too many cases, case 1, case n, if the value here, value 1 is, if the value 1 is similar to this expression, so we'll execute this statement. If value 2, otherwise, if value 2 is the same as this expression, we will not execute this expression, we will execute this expression, and so on. If no expression are similar, is similar to any cases, so we will use otherwise. Otherwise, this means that we are going to execute the statement if no cases are similar to switch. So I think let's take this as an example. Now let's our expression to be named color. Now our expression is color. Assume that color sometimes it is equal to, so switch color. If case 1 is the same as color, so we will execute this statement. If case 2 is similar to this expression, so we will execute this expression. I think here let's copy and make example CLC. Okay, now as I said before, our expression here is color. Okay, now color is stated to be equal to. Sometimes it depends on our program. It is just an example. Okay, now it is very important that this expression is similar to what's before. Sometimes it is color, sometimes it depends on our objective. Okay, now switch color. If case 1, if color equal 1, so we will execute this statement. If color equal 2, so we will execute this statement. In our case, color equal 2, so we'll execute case 2, which is this color is green. So enter. Now the answer is color is clear, green. Now, okay, assume that color here is not here 1. In this case, case 1 is executed because it is similar to the expression. So now color is red. So let's make another example. Assume that the color is equal to 1 1 1 1 1 1 1. Now there is no such cases that equal to 1 1 1 1 1. For example, I think case 1 never executed, case 2 never executed, as well case 3 never executed. Now the otherwise case will be executed, which is display color is not white, not blue, not green. So color is not white, not blue, not green. I think this is a good example that you can use it in order to understand the switch color. Okay, let's go back to our presentation. Now another important flow control, which is a repetition. In fact, for loops are most often used when each element in a vector or matrix is to be processed. Okay, let's take an example how to use for loop. Sometimes we want to repeat to execute a statement 5 times, 6 times, 7 times, 10 times. In this case, we want to make too many repetition. It is good practice to use for loop. So this is an example for loop. I think it is very easy and all of you is aware of it. So just an example. So now x equal 1, we define x to be equal 1. Summation, we define a summation, initialize it to be equal 0, and we want to make a summation from 6 times. It started from 0 to 5, and sometimes we increase the increment. The value of increment is 1. So sum x equals sum x plus 1. This summation is going to be repeated 6 times because this is the for loop. This is the for loop. After that, after we finish the for loop, the 6th repetition, in fact, we will print the answer print f, which is very known for you. The summation of x is d. It is the summation of x. Now the value of summation, the value of sum x is now written here in d. Sorry, Okay, now the answer here will be the summation of x is 6. Summation of 6. I think it is good practice to be aware for to such flow control. Flow control, sorry, for loop is used once we want to repeat the statement, the execution of a statement 6 times. For example, in this example we want to repeat this statement 6 times, so we just build a for loop starting from 0 to 5. 0, 1, 2, 3, 4, 5. So it is 5 starting from 0, so it is 6. So 6 times, now the value is 6. Okay, now let's go to our lecture and see if there is something to talk about. Now yes, while loop is another repetition or looping flow control. While loop are most often used when an iteration is repeated until some termination criterion is met. So it is used when we want to just still, in this case, while loop is used until the expression the expression is met. Now let's take an example. This is an example, so copy. Let's go clean screen. Okay, now as I said before, we will initiate epsilon to be equal 1. Now what does it mean? This means that while 1 plus epsilon is greater than 1, keep executing this statement, which is new epsilon equal epsilon over 2 end. Now if this expression is true, keep executing this statement. Otherwise, if not, so go out from the while loop. In this case, I'm starting epsilon to be equal 1. Now while loop 1 plus 1, it is 2. So it is 2 is greater than 1. 2 is greater than 1, so keep iteration, using your iteration. Good. Now after executing this, we will go back to check. Now epsilon not equal 1, it is not, it is equal half. So 1 plus half, it is 1.5. So it is still greater than 1. So execute this. You will keep executing until making while loop is not greater than 1. So in this case, we will exit from the while loop. So now epsilon equal 1. For example, you can also make too many examples in the future. Okay, so let's see if there is something to say about. Okay, now the last thing is we want to explain the main difference between break and return statements. In fact, sometimes the break and return statements provide an alternative way to exit from a loop construct. Break and return may be applied for loops, for loops and while loops. Now, break is used to escape from an enclosing while or for loop. Escaping. Execution continues at the end of the enclosing loop construct. Return is used to force an exit from function. I think here it is very easy to understand this. Break is used to escape the current while or for loop. To escape from the current while for loop. Here the function, and once we reach the break, so we'll exit from while, but we are still inside the function. We are still inside the function, but we will exit from the while or for loop. But in the other hand, return is used to escape from the current function. So here, once we reach return here, we exit from the function and go out from the function. So if we want to go out completely from the function, completely from the program, we use return. But if we want to just go exit from the enclosing while loop or for loop, we just use break. So it is good practice to differentiate between a break and return. Break and return. I think I don't want to give some example for this in the future during explaining numerical methods in engineering with MATLAB. During application, I think we will have some example for this. I will start here and hopefully in the next lectures we will start in our main objective, which is numerical methods in engineering with MATLAB. I hope that our lectures in MATLAB will be important for you to start up numerical methods in engineering with MATLAB. Thank you very much, and see you in the next lecture, which is, I think it is lecture 7. Thank you very much.